Algebra 1, Lesson 48, Polynomials, Degree, and the Addition of Polynomials. Alright, a lot of what this section is about is some different definitions. And the first definition, or the first thing we're going to look at, is a polynomial. Poly means many, and it just has to do with the name that we give expressions. So if I have an expression like that, x plus 3z plus 4. It's a polynomial because of the number of terms it has. Anything separated by a plus or a minus sign makes it its own term. So this is a term, this is a term, and this is a term. And that is 3 terms. When you have 3 terms, you have a trinomial, which is a kind of polynomial. You can call it a polynomial. Most people call it a trinomial because there's 3. Alright, if we have 2 terms, that's called a binomial. If we have 4, or no, let's just say we have 1 term. 1 is monorail at Disney, monomial. Okay, 1 term. And you can call all of them polynomials, well, except the monomial. You can't really call something with 1 term many terms. But anyway, that's pretty much what we're talking about when we're talking about a polynomial. It's not a method, it's not a process, it's not how to solve anything. It's just a way to express what we're talking about there. Okay, so let's keep going here. If we're talking about the degree of a term, and I'm on the middle of page 194, it's the sum of the exponents of the variables in the term. So, if I have 6xym, alright, this has an exponent of 1, 1, and 1, so this has a degree of 3. I add the exponents together. If I have 4x squared m3, this has a degree of 5. So that's the degree of a term. So if I have 3x squared y plus 2xy, this one has a degree of 3. This one has a degree of 2 because there's a 1 and a 1 there. Alright, the degree of a polynomial. So that's the degree of a term. The degree of a polynomial is what is the degree of the entire kit and caboodle here. Okay, so this one has a degree of 1, this one has a degree of 3, and this one has a degree of 1. Alright, this polynomial is a 3rd degree polynomial only because one of the terms, the one that has the highest number of exponents added together, is 3. So that means the whole thing is of degree 3. So if I have 4x to the 5th plus yx cubed plus 2x squared plus 2, the degree of this polynomial is 5. That's pretty much it. And normally when we write our polynomials, we write them in descending order of one of the variables. So obviously we can't write it in descending order necessarily of all of the variables. We just pick the x here has a 5, and then we went to a 3, and then we went to a 2. So you pick a variable and you go down. And that's just, it's not wrong to put it in another order, but that's the way you put it in there when you're writing it. It's just a more correct way of doing it. Okay, so let's add some of these polynomials here. How do we add these guys? Alright, well, let's look at example 48.1, bottom of page 194. We have x cubed plus 3x squared plus 2. And we're adding 2x cubed plus 4. Alright, the thing we're going to do when we're adding is you can take off the parentheses, all the parentheses when you're adding. Always take them off. Doesn't change anything. It just kind of sticks everything together like that. And what we do when we add polynomials or add terms is we add like terms. Now, how do you tell when a term is a like term? When the term has, and there's 5 terms here, when the terms have the same exact variable, in this case they all have x's. Okay, so same variable. Alright, which they all do. This one, and this one. They all have x's. Next thing that has to be true is they have to have the exact same exponent. If they have the same exponent and the same variable, you can combine them. Alright, so let's look and see what we've got here. We have an x cubed, an x squared, and an x cubed. So this one and this one have the same exponent. We don't care about the number in front. Does it have an x? Does it have a 3? Does it have an x? Does it have a 3? It does. So I have 1x cubed plus 2x cubed gives me 3x cubed. And then I can get rid of them because I combined them. Alright, now I look at this one. I've got an x squared here. I don't have any more with x squared, so I can't do anything there except just leave it alone. Then I look here and here. Neither one of those have variables, so I can add those. And I'm done. Okay, so all I did was combined like terms. So let's look at the second example, example 48.2. We have 3x to the 4th minus 2x squared plus 3. Now we're going to subtract x to the 4th minus 2x squared, cubed. It's late. Plus x squared. Okay, so remember what I said. Let's put a parenthesis around this side here. What I said is when there's a plus sign here, we can take off all the parentheses and combine. When there's a minus sign, you can't do that. So we have one, well, I guess it's not really another step, but we have something else that we do there. We write the first one without a parenthesis. That doesn't change. But in order to take these parentheses off here, we have to change the sign of everything in between. So this here is a plus x to the 4th, so we'll leave it as a minus. Change the next one to a plus, and change the next one to a minus. Now we can combine. And what I like to do again, underline my like terms here with the sign. Let's put a square around them. Okay, so then we can subtract 3x to the 4th minus x to the 4th. Cross those out because we're done. Now we're going to look at 2x squared, and the sign negative, and x squared. So the variables are the same, as well as the exponent. So negative 2 minus x squared is negative 3x squared. So now those go away. And we have the 3 that we can't combine, and we have 2x cubed that we can't combine. Alright, so let's put them in the right order. 2x to the 4th plus 2x cubed minus 3x squared plus 3. There we go. That would be the correct order to put those in. Okay, so let's look at one more, and then we will be done with this lesson. So hopefully you've noticed it hasn't been too bad. Alright, so 3x cubed plus 2x squared minus x plus 4 minus x squared minus 7x minus 5. Alright, so we take the parenthesis off the first one completely. Because there's a minus sign, when we take the parentheses off, all the signs change. And notice this sign we just took the parenthesis off and it became a minus x squared there. Alright, so we've got a 3x cubed. I don't have any more 3x cubes, so we don't do anything with that. But I do have a plus 2x squared and a minus x squared. So 2x squared minus x squared is 1x squared. And that goes away, that goes away, that goes away. I've got a negative x and a positive 7, which gives me a plus 6x. And that goes away, and that goes away. Plus 4 plus 5 is that. Okay, the only thing I would change on here is I would get rid of the 1 here, and we would call that good. So that's it as far as combining like terms, and that's it for problem set number 48. I just want to go over something real quick here before I run out of time, and that would be practice problem A. Okay, and then there's plus other stuff here. What I'm concerned about is this negative sign right there. Remember what I said. On this one up here, there was a minus sign, so when we took the parentheses off, we changed the sign. Same thing is true here. When we take the sign off, everything changes its sign. Like that. Then we do plus, and we can just take the parenthesis off there because of the plus sign. Okay? And that's what we've got. Alright, so that's it for lesson number 48.